So let's look at the board and let's talk about definition and the explanation of uh, the theory of light and comparing the particle theory of light according to Newton's and the principle of property of light based on Huygens' wave theory of light. So one scientist, Newton, is in the belief that light travels as a particle. So we're going to talk about the properties and the explanations associated to it on our screen on the left side. So here we can talk about Newton's theory of light, which explains that light is a particle. And then besides this theory, we have another scientist which worked on the same subject and believed that the light travels in a waveform, which is Huygens theory of light. And that is based on saying that light travels as a wave. Now, before we get into the differences, we want to see what is the main idea behind describing that water, the light particles are particles or are moving as a wave. What is the fundamental difference, which is also the main idea and the main part of the learning from a double slit experiment from Young's famous experiment of movement of light. So in that experiment, what happened was we have a screen and we have, I'm going to do the Young's experiment, which is the critical point of changing the idea of principle and theory of light in accordance of both Newton's theory and Huygens theory. So the question or the experiment is that we have a source of light, and this source of light is coming from left to right and is hitting the screen. And so this is two different rooms, and then we have another source of light hitting another screen here. So we have two experiments. Now we have the opening or the slit in the middle of the our wall or our screen, which is allowing the light to pass through. If Newton's theory of light is correct, or if this is the right explanation of behavior of light, which explains that light are particles that are moving with a very high speed, then some of the particles would pass through this point, and we will have few of the light's particles passing through the slit, and then if you place another screen here, what you would see is you would see a very bright point here, which are the particles that are passing through that specific opening or slit that we designed. So this is our opening or our slit, which allows the light to pass through, and this is our screen. And if light travels in a waveform, as Huygens was explaining, after some of the light waves pass through the opening, they would not go through one single straight line, and they would expand in both directions. So if you place a screen here, what you would see is you would see some light that is being expanded into a wider range of light, even though you're making only one small opening here. And Young's experiment went one step further and also made two openings in the second screen, letting the light pass through two openings in this case, which would what happen is some of the light that are passing through this opening, they're going to be also expanding again, and some of the light that are passing through this opening are going to also expand again. And what happens is, if light is really a wave form of movement, then we should see constructive and destructive interferences in this area, where the light from one source or one opening and another opening interfere with each other. So when these in this region, when the light from a source, let's call it one, and the lights from opening number two come together, they may come together in a form of constructive interferences, or they may come together as a point of destructive interferences, which, if that happens, it's just another proof or another evidence of stating that wave of light acts exactly like waves of water or waves of sound, which we have talked about previously when we were studying the water waves and sound waves. We talked about it in the previous sections that if you have water waves interfering with each other, and if they meet each other at this condition that they're both at their maximum, or they both meet each other when they're having the highest height, then they will add up and they will make a bigger wave. And that is how the formation of the waves happen in the ocean. Multiple waves coming from different directions, then they always join, either making it constructive, which is making bigger waves, or in some cases, when they meet each other at a condition that they are not in the same basically phase, then they will create a destructive interferences. So we can briefly look at destructive and constructive interferences here as well. Constructive interference and destructive interferences. So a simple diagram for it would be, if two waves, wave 1 and wave 2, happen to meet each other in a way that their maximum are lined up in the same phase. Their maximum are lined up in the same phase, and their minimums are also lined up in the same place. When these two meet each other or join together at some point, they will add up. And what you will have as a result would be a wave, which is a bigger wave. So it will, the minimums will be almost like together. So it will make a bigger minimum and it will make a bigger maximum at those points as well. And if the opposite of it happens, which means if one of the lights are in meeting another at the point where one of them is at their maximum and the other one is at their minimum, something like the one that we're showing on the left. So when the red light is at its maximum, the blue one is at their minimum. What happens is, in that point, they will, if they are waves and if they are carrying energy, because one of them is positive, one of them is negative, in that situation, we will have no wave as a result. Now, when you're explaining this no wave or bigger wave conclusion of interferences in light, the results are going to be shown as basically brighter lights or darker lights. So what we will see on the screen here, we will see some lights, some points that are brighter and some points that are lighter. And this is again all because we want to show that light is moving in a wave form. The more constructive, the more you get closer to the center, you will see more constructive interferences, and the more you go towards the sides of the screen, you see less constructive interferences. There are a lot of pictures and experiments similar to double slit experiments, and this is not very different from the idea of double opening experiment or double slit experiment where we were doing it on water waves or sound waves. It's just the first time that someone did this on light to just prove that light is in a wave was turning point on understanding the behavior according to this theory. So based on these experiments, it was believed that light travels as a wave and it's not a particle. Later on, based on more experiments, it was also proven that light is a mix of two. So there were still some points in the theory of Huygens' theory of light, or all the other scientists that believe that light travels in a waveform. There were still some points that they could not explain based on this theory, and they had to go back to Newton's theory of light, which is based on saying light is a particle. For example, one of the arguments was that later on it was believed that light could be affected by gravity. And so if light is not a particle, if it's not an object moving in medium, how can it be affected by gravity, since gravity only works on objects that have mass? So that was one of the things that it could not be explained based on the light travels in a waveform, because waveform automatically it says there's no particle, it's just the transfer of energy, and energy is not an object that can be affected by gravity. There are some other examples of it as well, which could not be explained by pure definition of light is a wave. So today's definition, after discovering photons, which are the energy particles inside the light, the conclusion of the definition of theory of light is that light is neither the particle nor wave, but it has the properties of both. And that's the conclusion that we're going to look at in further chapters. But right now, we compared a Newton theory of light, which says it moves as a particle, which was proven wrong with so many evidence at the beginning of looking at the theories. Then Huygens' theory was saying, no, maybe light is in a wave. Then Young's double slit experiment kind of proved and stated the conclusion that light is wave, but still had some information and things missing from the conclusion of the theory. Therefore, it has been still going on, and the latest researches that has been done on the photons and the movements of light comes back to year 2020 and 2021, and it's still going on.